All right, guys, let's go ahead and get started on tonight's homework. Let me find my marker. Okay, so we're looking at number 1 is x squared minus 10x minus 24. And you have answer options A, B, C, and D. This is okay, so we have all 4 of these, and what we need to do is we need to put each one of these together to see which one matches the top. Let's start with the first one. To do the first one, we have to FOIL this, guys. We have to do x times x times 6. Let's do these two. Remember, x times x is x squared. X times 6, we're just gluing that together. X times 6 is just 6x. Negative 4 times x is negative 4x. And negative 4 times 6 is negative 24. Remember that a negative times a positive gives a negative. Okay? Now we're looking at combining under addition. The middle 2 terms is going to give us, the x squared is going to stay the same. 6 minus 4 is a 2x. And then we have the minus 24 on the end. Okay, notice this does not match because the 2x does not match the 10x. Let's go ahead and check the next one. Here we have x squared, negative 6x, negative 4x, and we have positive 24, okay? Now we take these two and combine them. We're going to end up with x squared, negative 6, negative 4 make negative 10, because you add, same signs you add, opposite signs you subtract, okay? Negative 6, negative 4, you add them up to make negative 10, and you have the positive 24 on the end. Why was this a positive 24? Because we did a negative times a negative. This obviously does not match. The negative 10 does, but the 24 does not. Okay, let's check part C. This is x squared plus 2x. Negative 12 times x is negative 12x. Negative 12 times 2 is negative 24. And now we have 2 minus 12. Remember, signs are opposite. We subtract. 12 minus 2 is 10. So we're going to get x squared minus 10x minus 24 because we take the sign. When we subtract these, we take the sign of the larger. Okay? Now, this one obviously matches x squared minus 10x minus 24. So we say that C is our answer. However, I will say you need to check all of these. Okay? Sometimes you can have multiple matches. In this case, x times x is x squared. X times negative 2 is negative 2x. 12 times x is positive 12x. And positive 12 times negative 2 is negative 24. Here we have 12 minus 2, which is going to give us a positive 10x minus 24. So we see in this case we only got one that matched, and that was answer C. Okay? If we get 2 that match, then we have to, I don't know if there's any examples on this page, we have to go with the answer that is the best answer, and I will probably touch on this later in the review. Not at this point. It looks like all of these have just a singular answer. Now, let's go over a problem where you have a coefficient of 2 in front. So number 5 says 2y squared plus 12y minus 54. Again, this is number 5 at the top of the sheet. Answer option A is this. Okay, so let's start putting these together. Up here, we have this additional 2 sitting in front. Now in class, I told you guys to put these 2 binomials together first. And let's go ahead and do the first one that way, and then I'm going to show you another way you can do it if you want. Let's put these 2 together first, and then we're going to put the 2 in last. So y times y is y squared. Y times negative 3 is negative 3y. 9 times y is 9y. And 9 times negative 3 is negative 27. And this is the multiplication of these 2, but since there's a 2 being multiplied out front, we still have parentheses around this with a 2 sitting in front. because multiplication still needs to take place. Now we need to distribute our 2. Okay, 2 times y squared is 2y squared. 2 times negative 3y is negative 6y. 2 times 9 is 18y. And 2 times negative 27 is negative 54. We have negative 6 plus 18 is going to give 2y squared plus 12y minus 54. And notice this matches. This is our answer, most likely. Okay, so answer option A matches up. So we're going to say that A is our answer so far. I do recommend that you check all of these. Let me show you answer option B, another way to do this, and then we're going to move on to the next question. For example, on answer option B, if this 2 is sitting in front, you can distribute the 2, but if you distribute the 2, you can only distribute it to one of the binomials. So like this, 2 times y gives a binomial of 2y, and 2 times negative 3 gives a negative 6. And then you still have the y minus 9, and you're going to now FOIL this. 2y times y is 2y squared. 2y times negative 9 is negative 18y. Negative 6 times y is negative 6y. And negative 6 times negative 9 is positive 54. Negative 18, negative 6 make, remember same signs, we add them up. This is negative 24y plus 54. Okay. This is not working because we have no match. Okay, I'm not going to do the last 2. I think the last one explains it. What I'm going to do is I'm going to just give you the answers for the rest of the homework questions. Okay, for number 2, the answer is answer B. For number 3, the answer is B. I want you just to show your work. Show me that the answer is this by just putting it together, okay? Number 4, the answer is, let's see, looks like answer B. Yeah. Number 5 we just did. Number 6, the answer is answer B. Oh, here's one where there's 2 answers. Which one is it? I want you to put answer B together and answer C together. Okay, put them both together. Which answer is it is my question to you. I want you to choose which one you think is the right answer. Both of these will give the right answer. To part B, I didn't see that there was another one that matched. Okay, number 7, the answer is A or D. Okay, and I'll give you guys a hint. On number 7, the correct answer is D. If the correct answer is D on number 7, can you figure out which one is the correct answer on number 6? Okay, so put them both together and see. Number 8, the answer would be it would be D. Okay. All right, the back page you do not have to do. Okay, you just need to do the front page. In the back of that page, you can cross this out. You don't have to do these problems. Let's go to the very last page, the rational and irrational numbers. I'm just going to give you the briefing on the lesson that we did in class. Okay, so rational numbers are defined as fractions. This is really most any number you can think of. Fractions are represented by decimals that repeat, or like this, 939393, or 0.142857142857, and this continues in a repeating set of 6 digits. By the way, this number is the same thing as 1 over 7. This number is the same thing as 1 over 9. These are all fractions, guys. And also numbers, fractions represent decimals that repeat, and they also represent decimals that terminate, like 1/4 is 0.25. Also, if you have numbers like this, $3.25 on a cash register can be represented as 325 over 100. So basically, any number you can think of that we use on a daily basis, like the number 10, for example, just a simple number 10. We learn to count to 10. That's 10 divided by 1. These are all fractions. Okay, they can all be represented by fractions. So think of rational numbers as numbers that make sense. Okay, the other are the irrational numbers. There's only two types of numbers in math, guys: rationals and irrationals. Well, actually, there's more than that, but in the real numbers are either rational or irrational. There is a set of numbers in math called the imaginary numbers, but we're not talking about that in Algebra 1. That will be discussed in Algebra 2. But in terms of the real number system, there's only two types of numbers: the rational and the irrational. Irrational numbers are numbers like pi. Numbers whose decimal 3.141592653589 . So this decimal goes on forever, but is random. Okay, so irrational numbers are numbers. E is approximately 2.718281, and on and on and on this thing goes. This is random. Square root of 2. 1.4142, and on this thing goes random. I don't know the rest of these digits. So, but these are all examples of irrational numbers. Numbers whose decimals go on forever, but they don't repeat, okay? And these don't make sense to us. Rational numbers make sense. What you need to memorize for your LEAP test is that a rational plus a rational, or a rational multiplied by a rational, or a rational divided by a rational, any operation, rational, subtract, anytime you have two rationals, either added, subtracted, multiplied, or divided, this will always result in a rational number. And you need to memorize the reason why. Whenever you add or subtract these numbers, the rationals, they always result in a rational because when you add, this is the reason. If you add, subtract, multiply, or divide, two rational numbers, the result, let's see, let me say this. If you add, subtract, multiply, or divide two fractions, because rational numbers are fractions, the result is always a fraction. Okay, that's the reason. So the reason that when you add or subtract, multiply, divide two rational numbers that you always get a rational, it's because if you add or if you do the operation of addition, subtraction, multiplication, division on two fractions, you always result in a fraction. Okay, you can say a rational number is a fraction, and if you add two fractions, you get a fraction. A rational number is a fraction. If you subtract two rational numbers, you get a fraction. I'm sorry, if you subtract two fractions, you get a fraction. Basically, speaking of your reason in terms of fractions. Now, for this, if you have a rational plus an irrational, or a rational multiplied by an irrational, wherever you have addition or multiplication where an irrational number is involved, the answer will always be irrational. If you try to take a number that makes sense and add it to a number that doesn't make sense, you're going to get a number that doesn't make sense. The reason why, I will discuss this in class. It's not appropriate, I don't think, to put, literally, to put out, like to do the why requires formal proof. And to give you guys a verbal explanation does not do justice. But I'm going to think up something that is going to suffice for your LEAP test. But really, there's no business asking why this results in the irrational without asking for what's called a formal proof. Okay? All right, with that said, you guys have a wonderful evening. I'll see you tomorrow.